But we have got a problem. We have got this little gap. Why do we have a gap? Because the more we move these to the left and right, the longer they have to be to overlap. And in fact, the math of this is simple. Actually, this is not true. It doesn't matter how far you move them. Because they have a thickness of 4 pixels, they each need to be 2 pixels longer on each direction. So all we got to do to get a nice overlap is add 4, basically add the width. Whatever I choose here, if I made this 8, I'd have to make this 8. So let's add 4 to each one. If I can type, put that back to 4, save it. Now we have perfect hallways. Exactly angled, overlapping, no extras. Everything it's starting to look real good. But we're not quite there yet. Now let's move on to the step which is sort of what I call beautification. What we really like to see is something that at least approaches, if we forget about these extra hallways in the background, just the main hallway, we want it to be blue with a little bit of a glow, with a different blue, so that people can clearly see what's going on the screen. So let's do that. The way we do that is I basically took a screenshot of this into my, I don't have Photoshop, but you could take it into Photoshop. I did a grab, and I said, what is that color? What is this color? What is this color? And I pulled the color codes out, the hex color codes. So the hex color code that I pulled out for the hallway edges, the walls, was 0x A8CBDE. But for color codes in Corona, we need to split these up into RGB. So if you have a color code that is AABBCC in hex, all you got to do is take the first 2, second 2, and the third 2, split them apart, say 0x because it's a hexadecimal number, 0x, the color code. So if this was AA, I'd put AA. Take that now becomes a number, which will be calculated by Lua, and then divide it by 255, because the hex color codes that you're going to be using in your program will be 0 to 255. So long story short, I snagged the color from the image. I figured out that the first part was AA, the second part was CB, and the third part was DE. For that, I then split them up, put a 0x in front of it, divided by 255, and I created this table. Why did I create a table? Because I didn't want to type this every time. So if I create a table with entry 1 is the red part, entry 2 is the blue part, and entry 3 is the green part, later I can call set fill color, and then I can use this Lua function called unpack and pass the table. And this right here would be the equivalent of if I had typed this every time. But now, if I wish to adjust this color, I can simply adjust it up here, like make it more green or blue. Now I don't have to type these 2 lines again. And any place else where I use the fill color, it's all done because I'm using this table and it's used over and over. Okay, so let's do that. Let's save it. Okay, now we got a kind of blue edge. Now let's add the path background. So adding a path background, kind of tricky. What we're going to do in practice is we're going to draw a rectangle over this segment right here, and we're going to just basically draw a fat rectangle that is as wide as the hallway is from here to here. But this is going to create for us a problem because it's not going to completely fill the hallway. So we just drew basically a rectangle here, but there's little gaps missing. The other thing that we have trouble with when we do this is how wide is this rectangle supposed to be? It's not actually the width of the hallway as we've chosen it, because the width of the hallway is horizontally a certain distance. This is another one of those math problems. Because we've rotated it to a 45 degree, the true width from this line across the segment to this line is the width that we chose horizontally divided by the square root of 2. So let me be clear. If you have a 100 pixel width horizontally, and then you rotate it to the left, that's not right. Okay, no. So if you'll recall, what we've done is we drew 2 rectangles, and then we moved one a certain number of pixels, let's call it 50 pixels to the right, another one 50 pixels to the left. Well, that doesn't mean that the point between here and here is 50 pixels. That's not right. The distance between here and here is 50 divided by the square root of 2. The distance between here and here is 50 divided by the square root of 2. It's just a math question. So what you'd see if I had not done that, if I'd said assumed that it was the width of the hallway, is you would get this. This is the true width that we tried to achieve for the hallway. So from any point horizontally here, straight across, is the same distance as here down at an angle. It's wrong. It's too thick. It's actually, the hallway is not quite 100 pixels wide. It's closer to like 78 pixels wide, or whatever it is. Square root of 2. Anyways, so let's put it back. So easy trick. 45-degree angles are wonderful. For people who are familiar with the Pythagorean theorem, the other way to do this is to figure out, well, how tall is the rectangle or the triangle, and how wide is the foot, and a squared over c, a squared plus b squared equals c squared, or whatever the heck it is. I can't even remember the dang thing right now. You could apply that, but 45-degree angles are beautiful because the shortcut to that is the distance is basically whatever the width was you had divided by the square root of 2. So just follow my code, I guess. Really, yeah, we should do a math segment.
Somewhere my high school math teacher is pointing and laughing at me right now.
I know. I'm not doing a good.
No, you're doing a fine job. It's just
I'm not a math teacher, so I'm really bad at explaining. The problem here is I understand it well enough to do it, but not well enough to explain it to a layman.
Yeah, that's okay. But the point being that you would think that it's 50 pixels here, 50 pixels there, but it's not. And so
yeah, it's not. Because we didn't really make it wide. What we did was we just moved these things left and right. But then we achieved this segment here, which is some width. We just don't know what it is.
Okay.
The easy answer is it's the width that we tried to achieve horizontally, but divided by the square root of 2. Simple as easy as pie. So how do we solve this problem with these gaps? Because what we've done is we've drawn a rectangle that basically overlaps our original line. Great. The trick is, we know that if we think about it for a minute, that this is nothing more than a square that has an edge length of 1/2 the width of this hallway. So all we got to do is create a square that has this width for each of its sides. It's a square, and move it over by 1/4 of the hallway width, and rotate it by the angle, because you can see it. It's like, think about it. What is this? It's a square, rotated, certain width, easy. So let's go ahead and create a rectangle. Give it the width over the square root. So same value as this. Give it a fill color, and all we do is rotate it.